Hello everyone, this is our week 2 or module 2, and the first lesson I'm going to do here is about vectors. Okay, believe me, module 2 is a long one. We are covering 3 big chapters in this module. Okay, and if you look at web sign problems, there are 17 problems, 17, and don't be scared. I will help throughout these videos, and also I will post help guide for these web assign problems. If you are not familiar what I am talking about, please check discussion board general question area. You will find out help guide for even week 1. But week 2 I decided to give you more information, or in other words, I will show you a step-by-step work, and then you can compare it with mine, and everyone's numbers are different, but I will show you how to deal with these problems. Okay, all right, let's go ahead and start. This is a familiar picture what you see here. Okay, let me, and we know this compass we use if I want to find out the direction. In this case we use north, south, east, west, but in physics even it's still we are using north, east, south, west directions, but most of the time you would see instead that we are using x, y directions. Okay. Okay, let me go to the next slide. And in this lesson, we are going to look at few different things. We can look at what is the difference between a scalar and the vectors, and most importantly, the components of the vector. This is really important, and for some people it's really confusing. I will try my best. And then using this component method, we will learn how to add or how to subtract vectors, mostly adding vectors for our class, because this is a long chapter. As you see, it's very condensed in our setup. Okay, what is a vector? And the scalar quantity. Any physical property I could define, or I could categorize into vector and scalar. Okay, for an example, let's see. So let me try to use this pen. And so let's say you are somewhere here for this. If I use this diagram, somebody is asking how to go from you are here, library. You just say, okay, walk half mile. Okay, I'm pretty sure these people or the person will be very confused, because you can go from here to here, here to here, here to here, and he will have to do multiple trips to find out the library, because you missed some information because you did not give the direction. Okay, and for that, and any property, if you have something with magnitude and direction, we call it's a vector quantity. And in daily life, we mostly use scalar quantities, right? A scalar is a quantity what you can use with a number and a unit. On the other hand, vector is a magnitude and the direction. Magnitude means how big that one is. Okay, and books, because these are two different things. And if I want to tell you about the vector, and you will see, let's suppose, right, this vector can be A, B, or anything, I would put a small arrow on top of this letter. Okay, vector. Some textbooks use, because this is another job to put an arrow on top of that when you type things. Some books use italic bold color, so that reminds you it is a vector. Then how do I write a scalar quantity or the magnitude or how big that vector? This is the symbol. Just you use A or just you use this one. So these are two different things, because this gives you the magnitude, or it's talking about the scalar quantity, and this one is a vector quantity. Okay, let's look at some so this is covering, right? Okay, so let me okay, as we've seen this one earlier too, scalar and the vector. And let me, this is so annoying, let me pick the mouse, and these are some scalars and vectors. And meanwhile, so let me vectors and scalars, as you see here. Vectors, let's look at this one first. You could think many of those, right? Distance, temperature. Temperature is 32 Fahrenheit, 0 centigrade. You don't see any direction. Mass in kilograms, grams, energy in joules, time in seconds, but you do not mention any units here, direction here. But on the other hand, if I come to this section, last class we talked about the so let's see, last class we talked about the displacement. What is displacement? Remember, displacement is change in position. It is a vector. In math format we learned that this is my delta x, final position minus initial position. And velocity, velocity has magnitude and direction. Even though we use daily life velocity and magnitude for same thing, they are different. Now you can think what your speedometer shows. Does it show you velocity or speed? Your speedometer, when you go 65 miles per hour, it does not show you any direction, right? Therefore, it comes to the speed. Acceleration. Acceleration is change in velocity. You talk about those things in discussion board. And acceleration, final velocity minus initial velocity. Force, we are going to look at this one this week. Okay, whenever you look at these components or these vectors, we need to look at the directions. Okay, so this is when I switch the modes, it is annoying, and I'm trying to keep those on my slides, but it looks like they keep coming. Okay, and we are going to write, if I want to draw a vector, this is how we would draw a vector graphically. You would draw an arrow, okay, and from here to here, this is the length, and this length is the magnitude of the vector, how big your vector is, okay, and this gives you the direction. And for us, we do not have time to go over more in how to do the graphical, but what you should know, these are vectors. In other words, look at that, this is same direction and parallel, but they are not in magnitude wise. Let's say this is my vector A, this is my vector B. They are in the same direction, but they are not equal. Why? Even though they are same, and parallel same direction, but magnitude wise from here to here and here to here, these lengths are different. Okay, but if I draw, let me try something like this: vector A and vector B, and now look at that. And here vector A, I could write vector A is equal to vector B, because now they are lengthwise, let's assume they are same. Same story here, I am looking at anti-parallel. That means you have vectors in opposite direction. If I have something like this, A and B, so let's assume these are same length, and vector A and B, same magnitude, but in the opposite direction, then I could write my vector A and B are same but in the opposite direction. That's why this negative sign. Negative sign tells me the direction, and it is opposite direction. Okay. Again. And okay. And let's focus how to add vectors, and since we have no time, we are not going to do those things in textbook. You might see those things, but we are going to focus on how to add vectors algebraically using component vectors. Don't be scared, we need to see what component method is. Okay? And so let me try to switch to a slideshow. This one maybe I should be able to keep those drawings. Okay, and we are here. No, it's not. Still, it is here. Right? All right. So let's look at this one. Let me switch it here. And I will post a PowerPoint presentation as well, because if something is covering here, you could use my PowerPoint presentations. And let's look at this diagram. And here, okay, you are going to go from here to here, and then you turn and you go to length 3 blocks, right? Okay, 3 blocks to the west, 3 blocks to the right. And now instead that, if I want to figure out my displacement, we know that from last class or last lesson, displacement depends on your initial point and the final position. Okay, and displacement is here, final position minus initial. Okay, and if I can find out this distance, and instead from here to here, these are difference. Distance would be, let's say you go 3 blocks, 3 blocks, 3 blocks to here, 3 blocks to here, and but from here to here it is not 3 plus 3, 6. Okay, we'll see this how we are going to work on, and we'll have to look at some trig here, trigonometry. Don't be scared. I will show you how to work on those. And this is just a trigonometric review if you have not seen this one for a while, and you don't need complicated things. This is how this is what we are going to use over and over and over. You should know what is the definition for cosine theta, sine theta, and tan theta. Okay, for that, first what you need the right triangle. Okay, for an example, if this is the angle I am interested in, this is my theta, then sine theta is defined as, you cannot change, I cannot change, if you don't like this one. Okay, this is the theta. Let's call this length is A, this length is B, this length is C. Then sine theta is leg opposite to theta. In this case, this is my right triangle, and let's call this length is A. So then sine theta would be A over this length, this is C, A over C. Cosine theta is adjacent, leg adjacent to theta. Okay, and this is B, and hypotenuse would be C. Tan theta is opposite A over B. Okay, and you don't need again complicated things here, but you should know easily what are the definition for sine, cosine, tan. You could write in your notebook, or you can work, you can write whatever the way you want. Okay, all right, now let's look at how to get the components. I'm not going to use anything new. I'm going to use whatever we just learned, and which is how to get use the cosine sine relations. Okay, and let's look at here, and this is my x direction. I would call this as my positive x, positive y. Okay, and now this is my vector A. Okay, I have a vector A here. Okay, now I am going to get the components. Okay, components means instead this A, I project this vector into x and y direction. Okay, component mean I just get, right, I want to get rid of this. For that, what I do, I project this one into x and y directions. Okay, and make sure again when you do that, this is my positive, this is my positive. Okay, what you can do, you put your, if you're not sure what you should do, okay, and what you do, you are going to put your pen along this and rotate this one until it hits the x-axis. Then you would see your pen is lying and tip is along this way. Okay, this length we call AX. Make sure AX is not equal to, don't worry about this too much, because this is the vector, I just set this length. Okay, but if I look at this arrow, you would be right, this is AX. Okay, and again, if I project this one into y direction, you would see something like this, right? Why it is not writing, and something like this. This is your y, but this one and these are parallel, so therefore I could say it's because the same length and the same direction, therefore I could write this as my AY. Okay, and because we did not learn how to draw graphically, that's why I can't explain it here, but now this direction is AY and it is going in the positive y direction, therefore this is also positive. That's why we call this is positive, because my arrow is in the upward direction. Okay, now what I need to look at, or I need to figure out what is this x, AX. AX we call x component of the vector. Okay, and these components are sign numbers. What that means? Okay, sign numbers. Sign numbers means these could be positive or negative. Okay, first let's figure out your ax and ay because this is really important. And what I do, I just project this one to x-axis. Then I see my arrow goes to positive x direction. Therefore, my ax, first of all, I know it should be positive for this diagram. Ay is positive as well. Why? It's going in the positive y direction. Alright. And now, how do I figure out or how long that mathematically, how can I figure that out? For that, I am going to use my definitions. Cosine theta, I define cosine, I have a right triangle. Cosine theta I defined as adjacent length ax, and from here to here this hypotenuse is a. Okay, this is my cosine relation. It comes from the definition. It's not from my, I cannot change, as I mentioned earlier, you cannot change. That is the definition for cosine theta. Then since I know I need ax, what I did, I cross multiply. So that's why it becomes ax as a cosine theta. Same here, ay as a sine theta. Don't try to memorize because things could be different if I change my theta. Okay. This is okay. Again. Okay. Now it's the same diagram. Okay, and axy, ay, and I am just using the same thing since previous slide was kind of busy. Okay. All right. Now we know how to get the ax, ay, and now what is this? If I want to find out, let's suppose I know here, I know ay, and both are positive. If I want to figure out what is the length from here to here, we know a is not equal to ax plus ay. Why? A. Look at that. I did write this is the magnitude. Okay. And if you have a right triangle in math class, you must have seen. Okay. And make sure earlier I wrote a as ax plus ay. This is correct. This is not. Think about what are the difference, because here I'm looking at the magnitude from here to here length, here to here length. This is not right, because in math class if we have a right triangle, you know how to get this distance, which is a Pythagorean theorem, right, equals ax squared plus a y squared. Okay, and from that I can find out this should be a squared. Okay, that's how you have the square root. Or if I want to get the direction, I could write tan theta equals ay over ax, or theta is the arctan. Okay? You do not have to worry about this one. I would skip. So let's say skip. All right. So this is another important one. Okay. And sign of components, because I said that I mentioned that vectors are sign components, and because sign is very important. All right, so let's look at here the first one in detail, and then after that you can figure out everything else. Now my vector is here. Okay, I'm doing this one really slowly because I know most people get confused this part. Okay, so let me break this one to 4 quadrant A, B, 1, 2, 3, 4. Now my vector is in the 4th quadrant. Okay, and you can do the math, you can do everything to figure out AX, AY. My main job is here. I'm trying to show you how do I figure out the sign. Is it positive or negative? Okay, I wish I could, if I put the video I could show you, but you put your pen along here, and now AX means you project this one to X axis. Okay, and when you do that, try to make it use the small angle, then because you can project up to here, but small angle less than 90, and in this case you are projecting into here, right? Then you would see this one as, so let me draw, let me try different color. I don't see. Okay, and you would see from here to here as AX, and then you small angle you rotate up to here, and you would see this as AY. Okay, if I complete this right triangle, this AY and this AY are same, then you are seeing something like this. Okay, this is my AX and this is my AY, and this is the vector A. Okay, I'm looking at diagram A, and now you look at that. AX is, because this is my coordinate system, this is positive X, this is positive Y. Okay, so let's, okay, and AX is pointing in the positive direction, therefore this one. What do you think AY? AY is going downward, therefore this is negative. Okay, now if you know this angle, you could write theta, cosine theta would be A, because you do not look at the direction now. Cosine theta is opposite, adjacent AX over A, or cosine theta would be A cosine theta, sine AY would be A sine theta. That's how you would look at the sign. How about here? That's why you say AX is positive, AY negative. Can you figure out why this one? Now you put or you project this A to X small angle direction, because this is a big angle, right? Acute angle here. And now your AX is pointing to the west. Therefore, AX should be negative. AY is positive in the second quadrant vector. Third one, AX negative, AY negative. Here, AX positive, AY negative. Make sure we are going to use this one over and over. Okay, this is a good example to check whether you understood, because this is, it's asking me to look at only the what is X component, what is Y component. So let's look at couple of diagrams here. So where is my V1? V1, okay, it's asking anything positive, negative, and anything zero. If I look at V1, okay, what is the X component and Y component? V1 is parallel to y-axis. That means it's everything is here. Okay, therefore x component is 0. I'm not going to calculate anything. v1y is pointing upward, therefore it is positive. Okay, and how about v2? Why this is 0? It's easy way to look at that in elementary school. So let's say you have a point P. How would I write this one? Let's say this is point x component 3 and something is in here Q. This is 4. Okay, and P is on x-axis, right? Therefore x component, let's say 3, and what is the y coordinate here? 0. If here you would write this one, it is on completely on y-axis, x component 0, y is 4, x coordinate, sorry. The same idea here. I'm trying to make things simpler, that's why I use this one. And now v1 is completely parallel to y-axis, therefore there is no x component. How about v2? And x component, we don't know anything to calculate, but it is pointing on parallel to x and positive direction, and y component would be 0 because it is parallel to x, or it's along the x direction. But this is different, v3. Okay, so let me try different color. Now v3 is here. Just put your x and y. This is my x and coordinate system, right? Okay. Now you break this one to bring this one to x direction. And then you would see your x, v3, x as here. Take your pencil and bring this one to x-axis. And this is positive because it is going in the positive direction. How about y? v3y, if you project this one to here, because if I draw this, this is going to be really messy. You are projecting into here and you are seeing something like this, right? Parallel to v3y. And my arrow is going in the negative direction, therefore this is going to be negative. So on try v5, v6, v7, v8, v9, and if you are not sure, just ask me. Later I will give you the answers. This is just to practice, because you need these basics to go and do the problems. In WebAssign, first 4 problems are from here, but you would not see this type. But if you understand this one, it would be easier and to go and check. Okay, and let me, all right, I forgot to mention that earlier. You need calculator to figure out what is cosine theta, what is sine theta, because you need the calculator, okay? Cosine theta, sine theta. And if you do not have a calculator, don't worry about that too much until you buy something. This is something, if you Google a calculator word, you will see this. You could use the Google calculator. Okay, and theta here are angles. Therefore, make sure your calculator has 2 options, radians and degrees. Everything should be in degrees. Okay, otherwise you would not get the answer. Make sure change the mode to degrees, not the radians. Okay, this is some extra information for you. Okay, so let's try. Okay, all right. So let's look at, okay, and a problem. Find the components of ax and ay for the vector a. Now this is a real problem, okay, whose magnitude and direction are given by what is this? This is the vector magnitude and theta 66. Okay, all right. And so that means vector is given something like this. Oops, sorry, I'm messing this up. Let's use this. Okay, and instead writing, okay, now I have a vector A, and what is this? This A, and now it's given that this theta, and from here to here magnitude is given 3.5 and asking what? Find the components of AX and AY. Look at that. That's why we learned earlier. You have a vector A. Now it's asking me to find out AX and AY. And this theta is given. Don't be lazy. Write what is cosine theta, what is sine theta. Cosine theta is adjacent length AX over this length is A. So therefore AX would be A cosine theta. And I know this is positive, right? Positive. And A is 3.5, cosine theta is, what is cosine theta? Cosine theta is 66, you can find out AX. AY, what is AY? Sine theta is opposite AY divided by A. Therefore, AY would be A sine theta, and again this is positive. You can do that. Part 2. Find B and theta for the vector B with components. That's another way. Now you have a vector and both are positive. That means I know this vector is somewhere here, B. Remember that it's first quadrant because both are positive. And now this length is given, BX. I know BX, I know BY, this length is given. An angle is not given, asking me to find out the B. So that means it's asking me to figure out the magnitude of the BO here and the theta. Okay, nothing new. Again, it's the mathematical review. If you look at the trig review or a Pythagorean theorem tells me magnitude of the B is square root of BX squared plus BY squared. Right, okay. And how would you find the theta? Because I know tan theta is defined as opposite BY over BX. Okay, then tan theta is BY over BX. Then to get the theta, what you can do, you need to do the arctan or the second function of the tan. Okay, before you go to the next slide, okay, listen to this and do yourself, and after that you can check the answers. Okay, and me clear my drawings and you would see the answers. Okay, another practice one, determine the x and y component of each vector. And now based on what we learn, you should be able to do those things. Okay, I need the pen, and I'm sorry, and look at that. This is pretty straightforward. At least tell me what is AX, positive, negative. I can say AX is here this way AY is this way, then AX positive, AY positive, you have a right triangle. The first thing is you need to make your right triangle. That way your life would be really easy. After that, you know this distance, you know the angle, right? AX would be A cosine 40. AY would be A sine 40. How about here? What do you think? Okay. And now, look at that. If you complete your right triangle, this is going to be your right triangle, and you bring this one to here, right? This angle is theta, and your AX is going to be negative. Why? Because my arrow points this way, but your AY is going to be positive because it's going top. And you know this length is 1, you know the angle 25, use cosine sine relations. Same thing, mainly what you are doing is completing the right triangle. And this is the vector B. Now in this case, you are projecting this one to here. This is going to be Bx. So this is going to be By. You see that Bx is positive, By is negative, right arrow. At this point, you should you should be a pro of getting Bx, By angles. All right. Okay. Vector, another example, vector has a magnitude and pointing along the x-axis. Let's try to draw this because I'm trying to draw that vector. Okay. Vector A has a magnitude of 0.5 and pointing along the x-axis. Vector B has the magnitude of 7.5 and 30 above the negative x-axis. Okay, before you see, let's try to draw these two vectors. Okay, and this is my x direction, this is my y direction. I'm spending more time here because this is the basic of getting the component. Let's draw this. It says along the x-axis. Therefore, I would write my vector A as here, and this length is 5.5. How would I write draw vector B? And vector B has the magnitude and 30 degrees above the negative x-axis. Okay, and so that means, so this is positive, this is my negative x-axis, 30 degrees above the negative, so that should be my B. So this is 30 degrees. Okay, there's a type of y component of the vector A, vector B. That should be the problem, right? Okay. Now you could write here vector AX, AY. And we learned that this is along the x-axis. So therefore, it's parallel to x or y component 0. AX would be from here to here the length, which is 5.5 positive. How about xy? Determine the x and y component of the vector B. Vector B is here, and we did now multiple times. Bx should be negative something, By should be positive because it's going up. Okay, and you can figure out the numbers. Okay, and this is from your textbook. Okay, and it says it's drawing the vectors. Please go ahead and read. Now only difference here, and they are using different language to north of east, okay, and south of west to give you the directions. And so in that case, if I get this, okay, and so that's how north of east. You want to go to the east, now you direct in 35 degrees. And the other one south of west. You want to go to the west, but you go south 55, right? Okay. And you have, right, this diagram is given. And how far did walk on the east of the leg trip? Okay. And what does it mean? How far on the north leg? So that means, in other words, it's asking you to get the AX. And here AY. West leg BX. Okay. BX, right? Okay. And now what you do? You have the vectors, drawings are given, and you can find out AX, AY, BX, BY. Okay. Again, this is a very good practice, and now we did multiple problems to figure out how to get the BX and BY, and go ahead and do the math. Okay. This is really annoying because I decided to use Zoom instead PowerPoints, because when I record the PowerPoints becomes very big files. Some of you cannot open those properly. Okay. Anyway, so let me know which one you prefer. After second week, I will post a thread on Blackboard which one you prefer. Okay. All right. And these are the answers. In other words, this is just to get in the components. Another example, what are the magnitude D and the direction of the net displacement? Okay. Before I do any math, let me know what this problem about. Okay, let's say you are starting from here. You go 3.7 miles north, and you turn and you go another 2.25 to the east. After that, what you do? So what this vector C, if I write it, 3 meters, what is the direction? Okay, what would be the direction? This is my east. Okay, and now what happens? He goes to south, right? So if I want to write in terms of this language, 3 meters, 45 degrees south of east. And those are the 3 segments he go. It's asking the net displacement, total displacement from here to here. And make sure this displacement is a vector. This is not equal to, you cannot just add those 3.75, 2.25 and 3. That's completely wrong. Okay. If you do this one, 2.25 plus 3, this is wrong. Why? because these are vectors. You are adding something going 3.75 north, this is east, this is south of east, three different directions. Okay, therefore you cannot add vectors. Then how would I do this? And that's why we learn make your table. Okay, and that way you can do this one very nicely. You have three vectors A, B, and C. Find out the x component, find out the y component. Okay, and vector A, I could see easily x component 0. Why? It's going upward north or positive y direction, and y component it is positive 3.75. Y it is completely on y direction. This is my coordinate system. Okay, and B, I could say 0. This is 2.25. See what happens. Now you have a vector something like this, right? Okay, a vector in this way. This is my vector. See, if I draw this one separately, this is 45. And Cx is, you move this one to here. Cx is positive, Cy is negative. You know why now? Okay, ask yourself why it is negative, because I am going to look at that. My drawing is again not perfect, and you see that Cy is negative. Okay, all right, and you can figure out Cx, Cy, that's why we learned earlier. After that, you can find out what is the total displacement. In other words, I could write dx, add everything together, dy, add everything together, and finally, okay, let me show you the numbers. Okay. Okay, we all figured out why ax0, ay is here. This is known, this is known, this is, you can check. After that, now what happened when you adding those three, now you can forget about an ABC. When you add all together, you get your resultant vector. Okay, and you get something both positive. Therefore, this should be in first quadrant. Okay, see dx, dy. And then you can find out the d, because you know this distance, this is dx, and dy, so this is your dy. Once you have the dx, dy, you can look at here. Okay, by adding those three vectors means you just replace these three vectors by one single, which is we call d. Okay, another one you to practice and try this, and I put the answers here, draw the vectors and get the components. This whole lesson is all about vectors to get the vector components. Okay, more practice problems if you have time, because I know this is a very long module and more information, 3 chapters. Okay, this is I did not design those modules, so therefore don't get angry with me. Okay, everybody who is doing physics 1, do the same modules. Right, there are multiple sections, 10 sections, everybody is doing the same thing, but I'm trying my best to help you. Okay, and you can try those things if you have time. And up to here I put answers in detail all about first taking the vector components and figure out the positive negative signs. As you see, I did work on these in details. Once you know how to figure out the directions, the rest is pretty much same. Okay. All right. Let me stop recording here, and I will pause this recording another with a week 2.